All right, we're going to talk about real deal factoring. And basically, I just call it real deal factoring because we've done some factoring before. We did some factoring on monomials, we did some factorization, and we did factoring using distributive property. All those things are necessary and important for what we're about to do, but this is the hard stuff, okay? This is the stuff that is a little more complicated, so you just need to kind of pay attention. What I'm going to do first is I'm going to write down the steps that you're going to need in order to do the real deal factoring, and there's actually going to be two different sets of steps here in a second. Go ahead and copy these down, and then I'll go over an example. All right, the first step is going to be factor out the GCF if possible. And you really need to be making sure that you're taking notes, because if you're not taking notes on your own paper here, this is going to be tough. Okay? So factor out the GCF if possible. And again, it says if possible because it's not always going to be possible. Okay. The next step is look at the first term and the rest of these notes are going to be if the first term does not have a coefficient. So look at the first term, and if no coefficients, then, and this is where we're going to add some more steps. If there's no coefficient on that first term, then you're going to drop down and you're going to create two sets of parentheses. Okay, once you've created your two sets of parentheses, you're going to drop an X in the front of both sets of parentheses. Or drop your variable, whichever variable you're using, in the front of each set of parentheses. So drop your variable in the front of each set of parentheses. So factor the GCF if possible. Look at the first term. If no coefficient, okay? If no coefficient, then step 3 is to create two sets of parentheses. Drop your variable in the front of each set of parentheses. Okay? Then you're going to find factors of your L term that add to create your OI term. Okay, I know this is going to sound complicated right now. Just write down the directions, and as we're going over examples, have these directions sit next to you, and you'll understand what I'm talking about here in a second. Okay, the next step is place the factors 1 in each set of parentheses. And then box your answer. And check your work. Now, the actual process of factoring is not that difficult or that long, but I would recommend, because when they do get a little more complicated, you check your work. You'd hate to do all that work and get the wrong answer just simply because you didn't check your work quickly, or when you had a chance to do it quickly at the end of your problem. All right, so let's take a look at an example. Okay, before we get into an example of factoring, one thing I want to do is I want to do a little FOIL review. And the reason that we're going to review FOIL for just a second is because this whole deal with first, outer, inner, and last, okay, that's going to be used a whole lot, or referred back to a whole lot when factoring, because I think it helps you remember where you're getting these numbers from and where the terms come from. Okay, so our FOIL review. Let's say we have x minus 2 times x minus 8. In order to solve, if I asked you to simplify this or to work this out, you would FOIL. And what you would do is you would multiply your first term. Okay? That's your first term. That's where your f comes from. And then you'd have x times x is x squared. Then you'd multiply your outside terms. That's where your o comes from. So x times negative 8 is negative 8x. Then you multiply your inside terms. That's where your I comes from. Negative 2 times x is negative 2x. Then you multiply your last terms. That's where your L comes from. Negative 2 times negative 8 is positive 16. So when I'm done, next thing I need to do is combine my like terms, which should always be in the middle. Okay, so I'm basically combining my O term and my I term right here. And I end up with x squared minus 10x plus 16. So that would be my answer FOILed. Okay, this is just simply a review. Okay, hopefully you remember that. All right, now let's go ahead and let's start our first example for factoring. So when I factor, let's say I'm given the last problem, x squared minus 10x plus 16. We're going to use that last problem as an example. I just FOILed out the answer to get that. So let's see if I can factor using my steps in order to get my factors. Okay? Alright, so my first step, if you go back to the steps, is to factor out a GCF if possible. Well, in this case, x squared minus 10x plus 16, there is no GCF. There is no GCF. There's 1 is the common whole number, which you don't have to do that one. And then you have x that goes in there but doesn't go into all three of them, so there's no GCF. So then, if you're looking at your notes right next to you, your next step would be to create two sets of parentheses. Here they are. Then drop in your variables. I say your variables because you could have p squared or any other letter, but in this case we have x's, so I'm going to put x here and x here. This is our first term. How do we get x squared? Well, x times x. If I FOILed the first term, it's x times x, right? That's where I get my x squared. Now again, my next step says look at my last term. Okay, my last term is that one right there. That's where L comes from. It is 16.
Ryan Hargrove, if you're in the building, you need to come to the front office immediately.
Okay, so I'm looking at my last term, of 16, and I need to find factors of 16 that equal my OI term. Now remember, this is my OI term now because when I combine like terms earlier when I FOIL, it becomes one term. So the O and the I get combined together. That's why it's an OI term. So what I'm trying to do is I'm trying to find factors of 16 that, and this is my L term, so L equals 16. Factors of 16 that add up to negative 10, which is my OI term. Okay, so let's just start by finding factors of 16. Now again, the better you get at factoring out numbers, the less of this you're going to have to do. But I show you the whole process so you kind of know my thought process, you don't miss anything. So the first thing I'm going to do is I'm going to say, okay, a factor of 16 is 1 times 16. Now every set of factors has an opposite pair. In this case, the opposite pair of two positives would be two negatives. So negative 1 and negative 16. So my next step is to add them together. 1 plus 16 is 17. Well, I'm looking for 10, so that doesn't work. Negative 1 minus 16 is negative 17. So that doesn't work. So I have to look for another set of factors. Let's go at 2 and 8. And again, the opposite. Always write down your opposite set. Negative 2, negative 8. Okay, so 2 plus 8 equals 10. Well, I'm looking for negative 10, not positive 10, so that doesn't work. Negative 2 minus 8 is, in fact, negative 10. So this is the one I'm looking for. So here's my factors. So these two, negative 2 and negative 10, and negative 2 and negative 8, add together to equal negative 10. So what I'm going to do now, if you go back to your steps, it says, step 5 says find factors of your L term that add to create your OI term. We've done that. That's the negative 2 and negative 8. Okay, now we're going to place the factors, 1 in each set of parentheses. Okay, so what that means is I'm going to take this negative 2 and I'm going to put it here. I'm going to take the negative 8 and I'm going to put it here. Okay, if all went right and I did this right, that is my answer. That's my solution. X minus 2 times x minus 8. Now, if I check my work, which you should have remembered because that was the problem if we go back a thing, that's what I did to FOIL right here. Same problem, right? But let's just go ahead and check our work. So if we want to check our work, we just go back and redistribute it. X times x is x squared. X times negative 8 is negative 8x. Negative 2 times x is negative 2x. Negative 2 times negative 8 is positive 16. Does that match the original problem up here? It does, so our answer is correct. Okay, make sure you're writing down any questions that you may have so you can bring them to me in the morning or during class. All right, let's look at another example. So hopefully we had the hang of it. Let's see, or another example, let's say we have x squared plus 5x minus 6 Actually, let's not do this one. I'm sorry. Let's do x squared plus 2x minus 15. I like this one a little bit better. All right, again, first step. Does it have a GCF? Again, no GCF here. Next step, does it have a coefficient, a number out here in front of the x? It does not. So I can go ahead and drop down two sets of parentheses and drop down an x. This is a good thing. You don't want it to have a coefficient. I'm going to show you that factoring here in a minute. But when you don't have a coefficient out in front, it's a lot easier to factor. Okay? So drop down your sets of parentheses, drop down your two x's, and now go ahead and we're going to look at our last term. So our first term is taken care of. Go ahead and look at that last term, which is negative 15. We want factors of negative 15 that are going to equal up to 2. Okay, that's what we're looking for. That's our OI term, right? So factors of negative 15, negative 1 and positive 15. Remember, it has an opposite pair. That opposite pair is 15 and negative 1. I'm sorry, that's the same one. Negative 15, excuse me, and 1. So let's add them together. Negative 1 plus 15 equals 14. Okay, negative 15, and that's not what we're looking for. We're looking for 2, right? So that's out. Negative 15 plus 1 is negative 14. So that's out. Because we're looking for 2. So what's another set of factors? How about 5 and negative 3? And got to remember the opposite factor of negative 5 and positive 3. So let's add those together. 5 minus 3 is 2. That's what we're looking for. So these should be our factors right here. Negative 5, just check this one just to be safe. Negative 5 plus 3 is negative 2. We still want the positive, so that's out. So now take your factors and stick them in the parentheses. I'm going to put this 5 right here. And if you stick a 5 in there and there's no sign, that means you need a positive sign. So that's x plus 5. And then you have x minus 3. Again, if all goes well, that should be our solution. So the next thing I want to do is go ahead and check my work to see if I get this again. If I get the x squared plus 2x minus 15, so x times x is x squared. That's my first term. X times negative 3 is negative 3x. 5 times x is positive 5x. 5 times negative 3 is positive. 5 times negative 3 is not positive. It's negative 15. Combine your like terms right here in the middle. And you have x squared plus 2x minus 15. And it is the same as what we had at the top. So we did it right. Okay, I recommend, because it's the only, we're going to do a few more examples of a little bit different type of problem, but I recommend that you have these written down. I also recommend that you jump in your textbook, page 430, 431, somewhere in that area, and you do some of these odd problems to practice. This takes a lot of practice before you really master this skill. This is a complicated process. This is actually a little easier than what we're about to get into, but you need to continue to practice this and do whatever you can to get this down, because if you do it now, you'll be better off later. I promise you that. So please make sure you are practicing and have your notes written down. All right. I'm going to do one more example from the notes that we took today, because somebody in second period suggested that maybe we should continue to do this one on the video, so I think I will. Okay. So this example is going to come from the notes that we took today. If you remember, this was in the notes that we took in class today, which was 2x squared plus 6x plus 4. We did this one in class. And the first thing, remember, the first step is to factor out the GCF. Okay, we factored out the GCF today, and we took out a 2 because they all had a 2 in common, right? Because 2 was the lowest number. The factors of 2, the highest factor of 2 is 2. 2 goes into 6 and 2 goes into 4. So 2 comes out. Not all of them have an x. So we just drop our parentheses there. And what was left was 2 divided by 2 is 1. And then the x squared comes down. 6 divided by 2 is positive 3. There's no x to mess with, so the x comes down. 4 divided by 2 is positive 2. Okay? So now it's factored to what you knew today. This is what we did in class today. And we said, oh, for all we know, this is all we can do. For all we know, this is all we can do. But I said you can keep going. Okay, so we're going to keep going. Okay, so I need to go ahead and factor this other part that's left in the parentheses out. So now I go ahead and I've factored out my GCF. That's taken care of. Number two says to see if there's a coefficient in front of the x. Is there a coefficient in front of the x? No, we just factored it out. So go ahead and you bring down your 2 and drop 2 sets of parentheses now. Okay, now we're going to look at now we're going to drop in our x's. That gets our first term. Now we're going to look at this last term of 2. Find factors of 2 that equal up to our OI term of 3. Remember, factors of 2 that you can add together that equal 3. Okay? So let's look at the factors of 2. We have 2 and 1. And remember the opposite factors of negative 2 and negative 1, right? So 2 plus 1, that equals 3. That's what we want. Those should be our factors. Just check this one just to make sure. Negative 2 and negative 1 is negative 3. We don't want negative 3, so that's out. Okay? Now, take your factors and place them in the parentheses. So now I have 2 times, So now I just got to put x plus 2 and x plus 1. So now, if all worked out the way it should have, these are my factors. I have 3 factors instead of just 2 this time. Okay, so to check it, all I have to do is redistribute here. 2 times x is 2x. 2 times 2 is 4. Now I have 2x plus 4 times x plus 1. Now I FOIL. 2x times x is 2x squared. 2x times 1 is 2x. 4 times x is 4x. 4 times 1 is 4. 2x squared, combining my like terms right here in the middle. 2x plus 4x is 6x, so 2x squared plus 6x plus 4. It does match what we started with, so that is the proper factor of that problem that we did in the notes today. So extending that on. So that's one that has a GCF. Okay. Now, let's go back to our steps real quick. In our steps, we said, look at the first term. If no coefficient, then. Okay? We're going to change this. Okay? We're going to go ahead and we're going to create some new steps. So, here's some new steps that we're going to create. And I'm going to put on here factoring with a coefficient. Okay, so this is going to be factoring with the coefficient. So we still, step number 1 is still factor out the GCF. Step number 2 is still look at the first term to see if it has a coefficient. Okay, now, step 3, this is where it starts to change. If it has a coefficient, then we use the rooftop method. Now, there are several methods to factor, and I'm not opposed to you learning whatever method you're comfortable with. We are going to primarily teach the rooftop method because in Algebra 2, that is what we use in order to factor more frequently than anything else. I think it's pretty fast and efficient, especially if you're pretty good at factoring. It makes it really simple, okay? So we're going to use that rooftop method. Now, the first part of the rooftop method is to multiply the first and last numbers. Okay, not the variables, but the numbers. So multiply the first and last numbers. Okay? Once you do that, you're going to use the factors of that product to find your middle term. And again, this is going to sound complicated, and it's a little more complicated than the last thing that we did, but just write down the steps so you can have them next to you as we're going through these examples. Okay, the next step. You're going to rewrite your trinomial as a four-term polynomial using the factors you found. Okay. So here we're going to get bigger. We're going to have a 3, x squared plus 5x, or 2x squared plus 5x plus 16 or something like that. And then we're going to turn it into something bigger. You'll see what I'm talking about here in just a second. But once you've rewritten that as a 4-term polynomial, our next step is to group the first 2 terms in parentheses and the last 2 terms in another set of parentheses. Then factor out the GCF. If you do this right, the 2 parentheses remaining should be the same. So the remaining parentheses should be the same. Okay, almost there. And then next, bring down one of the duplicate factors and group the GCF. The GCFs. and then box your answer. And check. Okay, I know that seems like a lot. Please do not turn off the video here because you think, oh, this is too much, I'm not going to get it. It's a lot more in steps than it is if you kind of actually see the examples go through. So please don't turn the video off here. This is where you make or break yourself right here. Not knowing how to do this will really mess you up moving on the rest of the year. And you're going to need this factoring in order to solve quadratics, which is our next unit after this. Factoring does not go away. As much as people don't like it and as difficult as it can be and as complicated as it seems at first, it does not go away. But I promise you, the more you do it, the easier it gets. Okay? So let's take a look at an example. So let's say we have (7x squared) plus 29x plus 4. First thing we need to do is find the GCF. Okay, if you look closely, 4 is our lowest term. Does 4 go into 29? No. Okay, does 4 go into 7? No. Our next factor of 4 would be 2. Does 2 go into 29? No. Does 2 go into 7? No. So there are no GCFs here. This is no GCF. So our next step then, okay, would be to look at the first term to see if it has a coefficient. You do have a coefficient of 7. So then if we have a coefficient, now we're going to use this rooftop method. Okay, so hopefully you have your notes sitting next to you, and let's take a look at this rooftop method. With the rooftop method, we're going to do that. We're going to multiply the first and last terms. That's where our rooftop comes in. So 7 times 4 is 28. So now I'm going to look at factors of 28 that are going to add up to equal 29. A little bit different. Last time we just looked at the L term and found factors of the L term, which is at 4 here, and then we found factors of OI. But that's not going to happen here. Okay, there's no way I can find factors of 4 anyways that equal 29. So I'm looking at factors of 28 that could add up to equal 29. Let's go ahead and start. 1 and 28. And the opposite would be -1 and -28. Always do your pairs. So 1 plus 28 equals 29. That's what we're looking for. So that should be our answer. -1 minus 28 is -29. Okay, I want positive, so that's out. My next step says to rewrite my trinomial into a 4-term polynomial. This is what a lot of students want to do right now. Because of doing the other type of factoring, which we did do, the students now want to say, okay, that's my answer. X plus 1 times X minus or plus 28. But there's no way that can work because X times X does not equal 7X squared. So that does not work. This is not it. That's a big misconception that most students have, is they stop right there and say, that's my answer. Okay? That's not it. So what we have to do now is say, okay, let's rewrite this into a 4-term polynomial. So I'm going to rewrite this as 7x squared plus 1x, okay, plus 28x plus 4. Notice how I just changed 29. Is the value the same? 29 has turned into 1 plus 28, which is 29. The value never changed there. So now I've just rewritten this kind of longer. So my next step would be to, and these numbers came from right over here. So my next step would be to group the first 2 terms using parentheses. That's what grouping means. And the second terms. Now when I group this, I'm going to use my distributive property to factor out what they have in common. So in this first set of parentheses, 7x squared plus 1x, what do they have in common? They have an x in common. So I'm going to pull out an x. When I pull that x out, all that's left is 7x plus 1. So 7x squared divided by x is 7x. 1x divided by x is 1. Over here, if I look here, does 4 go into 28? It does. So 4 is one of my factors. It comes out. They don't have x in common, so that's it. So I'll put my parentheses. 28x divided by 4 is 7x. 4 divided by 4 is 1. So if you look what happened here, these two are the same. That's what's supposed to happen. These are my duplicate factors. So what I want to do now is group my GCFs. These are my GCFs right here that we just pulled out. And I'm going to group them together as x plus 4 because it's a positive 4. And then bring down one of the duplicate factors, which is 7x plus 1. This, if everything went well, is my solution. It's really not a whole lot more work. It's just a little complicated to remember this step right here. Got to remember that step. Okay, so let's check it to see if we're right. X times 7x is 7x squared. X times 1 is x. 4 times 7x is 28x. 4 times 1 is 4. Combine your like terms here in the middle. You have 7x squared plus 29x plus 4. Does that match the original problem up here? Absolutely. So we did that right. Okay, I know this is getting long. We're at 36 minutes and I apologize for that. I want to go ahead and I want to do one more example. It's a little bit different. Okay, last example. We have 2x squared plus 5x minus 2. Okay, first thing I want to do is factor out a GCF. Just to make it quicker, there is no GCF here. Okay, so my next step would be to look to see if there's a number in front of the coefficient. There is, it's a 2. So that number, now we need to use the rooftop method. So I'm going to multiply these first two numbers. I'm going to get -4. Okay, so now I have to look at factors of -4 that are going to add together to equal a positive 5. Okay, so let's start. -1 and positive 4. Make sure you do your opposite, which is positive 1 and -4. Add them together. -1 plus 4 is 3. Well, I want 5, not 3. 1 minus 4 is -3. Well, I want 5, not -3. So that's out. What's my next set of factors? Okay, I have 2 and -2. And there's really no opposite to this one because the opposite would be -2 and 2, which is the same thing. So now if I do 2 and -2, I have 2 minus 2, which is 0. So what happens here is that doesn't work. Are there any more factors of -4 that I might be forgetting? Okay, no, probably not. They're definitely not. Okay, so what happens is that this is what you would call prime. I cannot do anything else. I cannot go any further on this particular problem because there's no way it works. So what that means is that is as factors as it can get. There's no way to factor that out into other factors. Okay? I just wanted to show you an example of a prime. Again, I would go back and look at that last example before this one. Practice some of these. These are on page 438, 439 in your textbook. Give yourself some practice. We're going to do this in class tomorrow. You're going to be expected to at least be able to get started. Okay? So, good luck, and I will see you tomorrow. Again, I apologize for it being so long, but it is what it is.